Hello, okay, we're going to continue the ionic and net ionic equation. We were in the complete ionic equation stuff, which is 6 moles of 6 ions of sodium plus 2 ions of phosphate, which is aqueous. If anything is aqueous, it's going to be dissolved or it's going to be dissociated. And we have 3 ions of barium plus 2. And 2 ions of nitrate. All these are from the reactant side, and on the product side we have barium phosphate. It is solid. Remember that this cannot form an ion because it's a precipitation. It's a solid part. In the next slide I'm going to teach you, or I'm going to show you, how do we identify soluble ion, soluble compound from insoluble compounds. There is something called solubility guideline. We're going to discuss in the next video. And then sodium nitrate will be dissociated into sodium ion and nitrate ion. Okay, so this is, we call it a complete ionic equation. Now from complete ionic equation we go to net ionic equation. Net ionic equation. What's a net ionic equation? In a net ionic equation there is something called spectator ions. These are the ions which are on the reactant side and the product side, but they don't have any contribution for the overall reaction, so we're going to avoid them. So we have sodium ion here on the reactant side, sodium ion on the product side. We have nitrate ion on the reactant side, we have nitrate ions on the product side without any changes. So we're going to remove them. The nitrates will be removed from the product side and nitrate from the reactant side. Also, sodium from the reactant side will be removed by sodium from the product side. So the net ionic equation is what is left over. So from the reactant side we have 3Ba2, which is barium 2, and phosphate, which is 2PO4, 3 minus. And from the product side we have barium phosphate, solid. So this whole reactant and product, this is called net ionic equation. This is what we have. This is a continuation. It's a small piece, but it's a continuation of the previous video. On the next video I'm going to discuss about solubility guideline. That's very important, especially on the precipitation reaction. When you do a precipitation reaction, it's very important to find out which one would be a soluble compound, which one would be insoluble compound. Maybe I can give you some guideline for right now. The guideline would be, for the solubility guideline would be, there are certain ions that we can learn, that always they are hygroscopic. In other words, they can easily be soluble in water. So I can show you that. So the solubility guideline, like I said before, there are certain ions which can easily be dissolved in water. I can give you some example of those ions. A nitrate ion, for example, nitrate ion, acetate ion. They don't have any exceptions. They can be easily be soluble in water. So for example, if you have sodium nitrate, or if you have any heavy metals like silver nitrate or mercury nitrate, they can easily be soluble in water. There is no any exception here. They are soluble in water. So what it means is that any compound that has nitrate ion in it would always be soluble in water. If you have a compound acetate, for example, if I have calcium acetate, okay, this is also soluble in water. Soluble in water. There are also halogen groups like chlorine, bromine, iodine. Most of these halogen groups are soluble in water, except that except that if these compounds are mixed either with silver or lead or mercury. Okay, if these compounds are mixed, if these ions are mixed with either of the three heavy metals, they become insoluble. When it comes with sulfate ion, sulfate is a little bit tricky. Sulfates are mostly soluble with alkali metals. That means when we say alkali metals, it can be sodium or potassium or rubidium or cesium. They will be soluble. Any of the alkali metal mixed with sulfate, they will be soluble in water. But like when we have certain elements like barium or mercury or lead mixed with sulfate ion, is going to be insoluble. So you have, for example, sodium sulfate is a good example. It's aqueous, it forms soluble in water, it forms aqueous. If you have lead sulfate, PbSO4, it's going to be insoluble. So let's also look for compounds containing sulfide ion and compounds containing sulfide ion and carbonate ion. This is sulfide ion, sulfide, not sulfate or sulfide, but sulfide, IDE. Remember the difference between IDE, ATE, and ITE. Okay, IDE we use for a monoatomic ion, ions, and ATE and ITE we use for a polyatomic ions. That's the difference, a polyatomic ions. So sulfide is a monoatomic ion. So compounds of ammonium ion and alkali metal cations are always soluble in water. So if you have ammonium sulfide or alkali metals, sulfides, alkali metals react with sulfide, they are always forms aqueous solutions. They are always forms soluble in water. Okay. Other than that, sulfide is not soluble. Say, for example, if I have copper sulfide, okay, that's going to be insoluble in water. It's insoluble in water. Or if I have aluminum sulfide, that's going to be also insoluble in water. The only time copper sulfide will be soluble would be with alkali metals or with ammonium ion. With ammonium ion, it's going to be soluble. And carbonate would be my last example. So with carbonates, there is also some restrictions. Again, the alkali metals ion and the ammonium ion are soluble in water, in carbonates. That means, say for example, if I have sodium carbonate or potassium carbonate or ammonium carbonate, I'm going to put subscript to here. All these are soluble in water. They are insoluble in water. But other than that, carbonate ion is insoluble in water. So if I have calcium carbonate, or if I have aluminum carbonate, these are going to be insoluble. So this is how solubility and insolubility will come here. I'm going to give you more examples in the next video as well. Thanks for listening. This is a continuation of the previous video. If you have any comments or any suggestions, please don't forget to put your comment in the video tab. And at the same time, if you have questions that you want me to explain on the video, I'll be happy to post for you. Thank you very much, and I'll see you in the next edition.